Alright, so I'm going to show off the destructible barricade and then just kind of walk you through how it's made. So you got the zombies spawning, they're coming through. You're going to smack it. It's going to play some effects. If I want to go up and repair it while they're attacking it, I can. Holding the use key, and it'll sort of pulse after every point, like 5 or 0.75 seconds. It'll pulse through, and then it'll run one repair function, and it'll just keep going as long as that key is held down. And if I walk away, once I get out of range, it'll stop repairing, and they'll just continue to knock it down. And I can shoot through them. I can stop them from killing it, and then go back and finish repairing it. And right now I'll just let them tear it down, so you see kind of what happens when it's broken. And here they come. So yeah, I'm going to show you the blueprint. I'm going to go into mostly just the blueprint for the barricade, and because otherwise the video would be way too long if I went into all the other stuff that triggers it. But so in the begin play, which is when the game starts, it just does a few things. It sets a max health variable. It gets the location of this in the world, because there'll be many barriers. So wherever that barrier is, we want to store that location. We want to get I'm sorry, it's not the world location, it's the relative location to its parent, which is the default scene root. So wherever that is, or I'm sorry, wherever the shown barrier mesh is in relation to the scene root, which is basically this little circle right here. So it stores that, and then it gets the material that's applied to the barrier mesh, and it creates a dynamic material instance, which is basically like just something that can be changed during runtime. So I can change the way it looks, and I'll show you that a little later. And it's got two real like main juicy functions or events: the repair and damage. Since it's going to respond to players repairing it and enemies attacking it, it has to basically do some different things when these events are called. So in repair barricade, of course, is when the player repairs it. It's first going to ask if the whether the barrier is damaged. The reason it's asking that is just so it doesn't allow you to repair it or call that function unless it actually has damage. And then it goes straight into this this function, handle health change, which is there's a little bit of spaghetti in here, but I'll just simplify it by saying that it basically takes in an input float, and it just says, like, for instance, here it's 20. It takes that and it adds it, and it could be a negative number. So in the case of damage, it will subtract it, but it clamps that health value based on this input between 0 and whatever and max health. Okay, that way the health can't go below 0. And then it just goes through this sequence node, and I don't need this. And it'll basically just determine, like, if the health is equal to max health, or in other words, if it is full health, then it's not damaged. So it turns off this boolean, and then it sets an enumeration property of no damage. So there's basically like 1, 2, 3, 4, 5, 6, 7 states for the barrier, and it ranges from no damage to completely destroyed. So the rest of these basically just, the second one goes, is the health less than or equal to 90% of max health? And if it is, then it'll show it'll set the state to extra light damage, and then it'll also set this damage boolean, right? And then it'll just keep going, and then the next stage is, or state is, light damage, and that's when it's 70% of the max health of the barrier, and it just keeps going and going until you get to, I just chose 98 for 98% of max health. If health is equal to that, it's destroyed, just because 100% would be 0. So there might be probably a different or better way to doing that. I just haven't had the time to do that. All right, so that's the handle health change, or handle damage. And then it just feeds directly into determine cosmetic mesh. And this function is, first it takes in a Boolean. Well, it takes in the state of the barrier, right? Basically you can't really see how it's returning it here. This return value is going into this function, and this will feed in the state of the barrier, and then this little Boolean switch thing is checked if it's coming from a repair. And since the event is repair, we can check that. And this one, when damage, is not checked, right? So we set the repairing Boolean, and then we go into a switch on enumeration node, which basically takes that enumeration property that I made, and it just starts to execute different things based on whatever enumerator was selected or fed into the function. So if no damage was fed into it, it goes up here and it sets a new static mesh, and the target is shown mesh. So shown mesh is basically the cosmetic appearance of the barrier. So every time this is changed, then a new mesh appears, among other things, but that's principally what it does. And then it goes to this macro here called configure damage cosmetics, and this will decide a few things. It'll see if it's destroyed, and that's something that I will switch on other down the sequence. But this is not destroyed when it has no damage. Of course, things that don't have damage are not destroyed. And this should block Boolean is the should block Boolean basically means that, what does it mean again? Should block. Okay, so should block basically just decides whether the effects that happen when the state changes are in relation to damage or repair. So for example, if I'll just show you. So when the state changes and it's being damaged, you want to have different effects, like planks falling or weird, debris like cracks and stuff falling out of see these planks are falling on the ground. That's when it's damaged, right? But watch when I repair it. Now it just has like kind of a haze, or like a kind of like a smoke from the construction of repairing it. But you don't see these particle effects like this because I'm actually not hurting it. And that's something I did just because I think makes it more dynamic and interesting. And it would seem kind of weird if players were like walking up and repairing it while it was like also simultaneously appearing to be damaged. So that this has two outputs, and they really are determined by whether it should block. I should make that more descriptive, like prevent effects or something like that. And then it goes into another function. I know there's a few functions in here. Grunge coloration, which has another switch on enumeration, which basically takes that dynamic instance that we made in the begin play, and it sets a parameter in the material that basically blends a grungy material with the wood as it's damaged. So you can see the material kind of is one way now, but see if you can notice any changes in the material as the damage increases. You can kind of start to see the grunge becoming a little bit more apparent. It's pretty subtle, but I like it that way, at least for now. So and you know what, just for the heck of it, I'm gonna show off the material really quick. So this is the barricade, the master material, and this is it's kind of important just to note that this barricade is designed to be subclassed by. So for example, if I didn't want a wooden barricade, I could have like a wire chain link fence, you know, or the door of a truck or something, and that could be a destructible thing. So I have a master blueprint barricade, which we're looking at now, and I also have master materials, and this is the material instance for wood, but the master material is here, and it has it basically blends between two layers. One is grunge, and the other is at least currently is actually just set in the master material. So these are 2D texture parameters. So in every material instance, or like subclass of this material, materials derived from this are going to be able to select their own textures and normal maps and ambient occlusion, metallic roughness maps. And currently all of them will be mixed with this grunge texture, and that could be changed later on. I don't know. I might do something so it's more dynamic for different destructible environments. So and this opacity, this dynamic parameter here has an opacity to control the dithering, because this is an opaque material. So this is actually pretty cool, and I'll just kind of show you really quick because it's really hard to explain. When the debris and particles fall to the ground and collide with the ground, there's a period where they'll stay, and then they'll sort of dither away, and you can sort of see them fade after a few moments. It's easier to see with the big planks. There you go. And I think it's a pretty cool effect. It's a nice like retro effect that works pretty well. So anyway, out of the material, we don't need to go over that anymore. Let's look at grunge coloration. Yep, we know that. Where am I? Here we go. All right. So after all this is done in the first part of barricade, we set the current damage level as a variable. That's important because the reason it's really important is because inside of this this determined cosmetic damage, there are a few places that I ask if the current damage level is equal to this like literal enum that comes before it. And the reason this is because we don't want zombies to like punch it, and if say like a zombie does a little bit of damage, we don't want to punch it and make chunks of debris and big planks fly every time they hit it, because then it just looks like the barricade is spawning like tons of planks more than it even has, and it looks really ridiculous. So storing this variable after here and then letting this check against that is super helpful to make the effects look more dynamic, believable. So right after that, I know it's a mouthful, you go into a play shake animation. I was not going to make this any easier on myself, so I decided to shake the wood also every time it's repaired or attacked. It will actually change the offset of the barricade. You can see it, and it sort of vibrates a little bit, and just to show you, it'll also vibrate if I repair it. And this works by using a set timer by event node, which is like basically this is the timer, and the time it fires every single time is 0.02 seconds, and it's looping. So as long as this timer is going, it will call this event here, and it'll call this function called shake barricade. And shake barricade will basically shake the barricade according to this integer variable called num shakes. All right, so, and this is the event shake barricade, and it goes right into a do n node, which basically just allows execution n number of times. And since this is connected, n is connected to num shakes, which is of course by default 7, then that means that this will allow 7 executions and to go through before it stops. So what I've got right after is a branch that checks the number of executions or counter against the number of shakes, and then it checks a boolean to see if it's equal. That way it doesn't just shake forever or never reset. So if number of shakes is equal to the execution flow, the number of shakes is equal to, I guess, 7, right? Which is, or how do I say this? If this is passed through 7 times, then it's going to set the relative location back to exactly where it was in the beginning, right? And then it's going to clear and invalidate the timer, which is, in other words, it's going to stop the timer. It's going to reset everything. That way, the next time it's hit or repaired, it'll be able to perform this again. And the reason I set the relative location back is because every time it actually shakes, it chooses a random float within like minus 0.5 and 0.5 on the x and y axis in local space. And if it shakes enough times, this random float value could create like an offset that increases over time. So you might have a match where, depending on how many shakes have happened to that barricade, it might actually start to drift away from that area. So to prevent that, I stored that relative location in the beginning, and I set it back to that variable, because this variable is never overwritten. It's never changed. And the way the actual shaking works was, I just showed you this little function. It'll just pick a random float within a certain range on the x and y, and then it'll set this relative location. So every time that shake happens, this is going to pulse through 1, 2, 3, 4, 5, 6, 7, and it's going to set that relative location. And once it hits 7, it's going to go whoop and set it right back to exactly where it was relative to its parent, which is the default scene root. And one of the challenges was getting the collision right. There's a few things happening with this bad boy. For instance, I have a block zombie volume here because players and zombies are technically the same class in this game right now. They're from the same blueprint, their functionality. So I needed to actually separate the pawn collision from the player collision. So I needed to offset them from the barricade so they didn't constantly look like they were clipping through the barricade as they were swinging their arms. So I created this, and I make it just block zombies but ignore player pawns. And this player pawn is a custom object, collision object profile thing I have. The FX spawn point, I'm up here in the components of this blueprint. The spawn point is basically where the effects will spawn. They'll spawn relative to this point, and I'll show you the Niagara particle effects in a second. And of course, I have this box collision here, which really the purpose of this is to block the player, because we don't want players to be able to walk through this after it's destroyed, but we want zombies to be able to walk through it. And that's really the reason why I mentioned that is because there's this final event down here, update collisions, or event, and it runs through this macro, and it basically just says, let's let's switch up some of these collisions. Let's take this block zombie block here, which blocks the zombie, and let's set it based on should block. So I guess I was actually wrong. I totally forgot why that boolean is there, but I think it actually helps with the effects too. But I think its main purpose, the reason I have this variable, is so that it knows when it should stop the zombie from going through the barricade. So if it should block, then query and physics and collision are enabled for that block zombie and for the shown mesh, and the collision response to channel, and the channel being player pawn or the player, it says block, which I probably would only need to be set once, but that's fine if it's set here every time. It doesn't really matter, I guess. And of course, if it shouldn't block, then the block zombie has no collision, which is the thing that blocks the zombie, so they get to run through when the barricade's destroyed. Okay, so I'm going to show you the particle effects. This is the folder for the barricade, by the way, and these are all the assets that comprise it. It's got about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. About 20, 25 different assets that make up the barricade. Not counting, of course, the zombies and all of the gameplay abilities and stuff that communicate with it. So this is the barricade dust Niagara system, and this is pretty simple. It's just has a few flipbook material nodes that are materials rather, and it will kind of show a nice subtle smoky effect and sort of disperse it around. But that's not quite as interesting as the barricade debris. And this is the barricade debris, and just to show kind of how it looks, let's make it infinite and let's just drag it onto the scene. Alright, so every 2 seconds it's going to spawn a new instance, or a new loop of that particle emitter, and this is what happens when the barricade is damaged. But it's not exactly what happens, because depending on the level of damage, either it will spawn heavy debris or light debris. So if I turn off debris 2, let's see. Oh no, I'm sorry. If I turn off these guys, these planks, then it'll just spawn the light debris. If I turn on the big planks, then you'll see what the heavy debris looks like. So as the barricade is damaged, the particle effect changes based on how much debris is specified. So in the beginning, it starts to have small little chunks. As it becomes more damaged, now you see the planks start to fall. And that's just to kind of add another aspect of like dynamic stuff to the emitter. Let's go over here. Change this back to 5 so once. So, and just to show you, lastly but not leastly, the dynamic material parameter. This is this little module or slot or whatever in the Niagara emitter. This communicates directly with the material of the plank, right? So in addition to having the big barricade meshes that change based on the damage, those states of the barricade, I also have individual planks for the particle effects, and they've got they actually have the same material, but they have a wait, what am I thinking? Oh no, I'm sorry. It's I'm looking at this heavy debris. So I've got a little user-defined variable here called heavy debris, and this is in the barricade. Oh, it's in here, and I didn't even show you the spawn fx function, which has, oops, here we go. So spawn fx is this function is run through on a bunch of these after configured cosmetic damage cosmetics, and it's got a choice between light debris and heavy debris. So if in the material if in the emitter this is set, how does this communicate with this? I forgot how I even did this. Where is this light debris? Is this in here? No, this is hold on. Okay, so light debris, heavy debris. Okay. And this goes in here. Oh, right. What am I saying? Because this spawn fx function spawns a new actor. I created a new actor class called barricade debris. So every time it spawns fx, it actually spawns a new actor. In addition to the barricade actor. And this is of type actor. This is of an actor class. And it basically will you'll pass in that boolean from the barricade when it's called, and it will set the debris level, and then it will do different things based on the debris level. So it'll spawn a system that this is the little debris, and depending on whether it's light or heavy, it will set that Niagara variable in here, heavy debris. It will set that, and it will give it a value, and by default it's 1, or I'm sorry, if it's heavy it's 1, if it's light it's 0. And why is it 1 or 0? The reason why is because the variable is the number of spawns in the spawn burst instantaneous. So if it's 0, it won't spawn anything. And if it's 1, it'll just spawn literally 1 plank. And these of course share the same variable, so they'll be. I'm sorry, not those. I meant these two emitters here share the same thing, so it'll be either both of them, like one of each, or none. So that's sort of the introduction, I guess, to how the barricade works within the barricade. There's a lot of other things happening on the outside, but like I said, it would take too long to sort of go into that right now. But thanks for watching. I love you, and have a great day. Drink lots of water. Goodbye.